So 5.1 talks about properties of exponents, and this lesson here we have two goals that we want to be proficient with by the end of the lesson. We should be able to simplify expressions that use exponents, and lastly we should be able to use properties of exponents to do a little bit of arithmetic with scientific notation. Before we dive in, it's sort of always nice to get some vocabulary and definitions out of the way. So just in case we forgot what scientific notation is, that is a number is expressed in scientific notation if it is in the form of some number c times 10 to some exponent n, where, and these are the conditions, this c has to be between 1 and 10, and n is an integer. So the exponents has to be a whole number, positive or negative whole number, and then this decimal part has to be between 1 and 10. So what are the properties of exponents? That's the main theme of this lesson here. So let's let the letter A and the letter B be any real numbers, and the letter M and N be integers. Again, the word integers means positive or negative whole numbers. What are the properties of exponents? So this will sort of be like a two-column chart here. The left, I'll put the name, and the right, I'll put the actual statements. So we have the product property that says if I have a guy that has an exponent and I multiply him by another guy that has another exponent and the bases are the same, that's key there. Notice the letter A's are the same. You can squish it together as one provided we add the exponents. The quotient property says the exact opposite. Instead of multiplying, if you're dividing two like bases, you can squish them together by subtracting the exponents. And notice the order of subtraction. It's always top minus the bottom. It's always the numerator exponent minus the denominator exponent. We have the power property. And this says if you stack exponents on top of each other, right? If you have an exponential expression raised to another exponent, you can mush them together as long as you multiply the exponents. Now, the power property is the closest thing you're going to get to the distributive property with exponents, because it doesn't matter what's happening on the inside as long as you're adding and subtracting, right? Well, this is what I mean here. Suppose I had a multiplication problem inside of parentheses and I raise it to an exponent. Well, because it's multiplication, you can distribute these exponents out to each piece. So that's A to the M times B to the M. And it works the same way with division as well. If I'm dividing and I raise it to an exponent, you can sort of distribute the exponent to both pieces. So that's A to the M over B to the M. Note, you can only distribute the exponents if there's multiplication and or division on the inside. If there's pluses or minuses, these properties don't work. These are sort of the three main properties. The next two are sort of like special cases, which are helpful. We have the negative exponent property that says if I have a guy that has a negative exponent, all that negative exponent does is flip the base. And it doesn't matter where the base started. If the base started in the numerator, it gets flipped to the denominator. If the base started in the denominator, it gets flipped to the numerator. Last is probably my favorite. It's the exponent property that says almost anything to the 0 power is 1. So there's no real secret to knowing properties of exponents. You just have to know these rules. If this is the first time you're seeing it, which it shouldn't be, but if it is, it just takes some time and dedication. Make flashcards, do whatever you guys need to do, but we need to know these 5 properties because applying them is simply knowing them. So what are some things that you're going to be asked to do? Well, you're going to be asked to evaluate, right? Suppose I ask you 6 squared cubed. Well, notice we have stacked exponents on top of each other. Which property talks about stacked exponents? Ah, this one here. And what does it say? All you got to do is multiply the exponents. Easy peasy, you're done. So that's going to be 6 to the 2 times 3, which is 6 to the 6 power. I guess I could figure that out. That's going to be 46,656 because, of course, we memorized all of our perfect 6. What if I asked you to do 4 to the 5th over 4 cubed? Oh, fractions. Everyone hates fractions. But the important thing is, notice how the base 4s are the same? Well, don't we have a property that involves dividing same bases? Sure we do. We have the quotient property, and the quotient property says if you're dividing like bases, you subtract the exponents, so that's exactly what you have to do. And it's always top minus bottom. So this is simply, without a calculator, 4 to the top exponent minus bottom exponent, which is 4 squared. Now that is a lot easier to figure out. That's 16. What if I gave you 7 to the negative 4th power? Well, we have a negative exponent rule. Well, what does the negative exponent do? The only thing that the negative exponent does is flip things. So notice how the base here is a 7. The base, the guy that's holding the exponent is just a regular 7. So if you flip a 7 or you take the reciprocal, that becomes 1/7. And the act of taking the reciprocal changes the exponent to be positive. And of course, knowing our perfect fourths, 7 to the 4th power is 2401. So that's one thing that we're going to be asked to do or be able to do is to do simplifying expressions. Now this was pretty easy because we had numbers. You can do the same thing if I swap out the numbers with letters. My hint to you: work numbers and letters one at a time. Don't get caught up in the fact that a problem might look ugly and messy. Just focus on one letter at a time. So for example, suppose I ask to simplify, it's going to be a fraction, x to the 5th, y squared, raised to the 3rd power, all over x to the 15, y to the 8th power. Very scary example. Now, technically, like solving, there are a multitude of different avenues, multitude of different paths you can take. My general rule is, this is sort of my general procedure, general process. I like to break down parentheses, and this is usually the power rule or the distributive property rule. I like to simplify the top and bottom separately. And this is usually the multiplication rule, the product rule. And then once the top and bottoms have been simplified separately, I'll go ahead and do the division rule. Right. Now you don't have to follow these 3 steps, but I find them a lot helpful if you are sort of systematic with it, because it can get confusing, especially if there's numbers and letters everywhere. So let's go ahead and do this. The first thing I want to do is break down any parentheses. Well, clearly we have these parentheses here, so that's going to be my first step. Well, what does an exponent outside of a set of parentheses tells us to do? Well, if you look back to our properties, anytime there's an exponent outside of a parentheses, we always multiply or distribute in. So that's the first thing we're going to do the distributive property with exponents and take this exponent of 3 and distribute him in. Notice how I'm not going to do anything with the denominator. So when I write down my first step, just copy him down. Any part of the problem you do not do, just copy it down. But we are going to do stuff to the top. So that's x to the 15, y to the 6. The next thing we're going to do is simplify the top and bottom separately. Now here's the idea. If a letter or a number, if a base repeats, that means you have to do stuff to him. So just focus on the numerator by itself. Ignore the bottom. So look at the highlight part. Do we have any repeated letters? And the answer is no. I only see one x and one y. So for all intents and purposes, the numerator is simplified as possible. Look at the denominator separately. Do you have any repeated letters? No, I only see one x and one y. So for all intents and purposes, the denominator is simplified as much as possible. Step 2, by default, is already done, so we can actually skip it. Then it's step 3, do the division rule. And the division rule says, if you have like bases, notice I have x divided by x and y divided by y, you subtract the exponents. It's always top minus bottom. So we do x top exponent minus bottom exponent, y top exponent minus the bottom exponent. So that's x to the 0, y to the negative 2. And then last but not least, you do more properties. Anything to the 0 power is 1, and because this y has a negative exponent, he's going to be moved downstairs. So this y squared goes in the bottom, and the x to the 0 becomes 1. We have simplified it. This is the simplified form. The last thing you're going to be asked to do on this, I guess let's just do one more example. I don't want to leave you with just one. Let's do 2. 2 is a good number. Suppose I ask you to simplify negative 2a squared b over a to the 5b cubed. Again, step 1, I want to break down parentheses. And parentheses, if there's an exponent outside parentheses, that usually means to distribute. You have to distribute to every single base. Now notice, there's some of these things that don't look like they have exponents on it. The b's doesn't look like they have exponents on it. The 2 doesn't look like it has an exponent on it. Anytime there's a number or a letter that doesn't have a visible exponent, there's always a 1 here. So you're going to distribute to every single exponent inside the parentheses. Also, if you have regular number, if you have a negative, always put that negative in parentheses. Next, you want to simplify the top separately and the bottom separately. Well, notice the tops. There are no numbers or letters that repeat in the base. I only have one negative 2, I only have one a, I only have one b. So it's simplified as much as possible. Same thing with the denominator. I only have one base a and one base b. So the top and bottoms are simplified. Last thing I gotta do is the quotient rule, is the division rule. Well, notice how the negative 2, he's by himself. There isn't a negative 2 in the denominator, so there's nothing I really need to do with him, so just copy him down. Move on to the a's. So we have a to the 6 and a to the 15. The rule goes, you subtract. So that's top minus bottom, top exponent of 6 minus the bottom exponent of 15, and move on to the b's. Top exponent minus the bottom exponent. When it comes to regular numbers like the negative 2 cubed, just figure them out. You don't have to leave them as exponents. So what's negative 2 times negative 2 times negative 2? That's going to be a negative 8. For the a's, we have a negative 9, and for the b's, we have a 0. Anything to the 0 power is 1, so we can basically ignore him. But this guy here has a negative exponent, so all you got to do is flip them. So there's your answer, negative 8 over a, and when I flip the a, the 9 becomes positive. Simplifying just takes practice, guys. Go ahead and practice them. Last we're going to talk about is doing computations with scientific notation numbers. So to multiply and divide complex numbers, the idea is very simple. Perform, or rather group, the decimals and the times tens together. Because when you're multiplying, dividing scientific notation numbers, everything is multiplying and dividing. So the commutative and the associative property of real numbers apply. Let's take, for example, suppose I ask you to divide 2.94 times 10 to the 8th power by 1.03 times 10 to the negative 2 power. Now this would be a very, very ugly problem if you had to do it expanded out. So you don't need to write this down. I just want to show you what it looks like expanded out. So that's 2, and then you have to move the decimal place over 8 times. So that's 294 with 6 zeros. 1, 2, 3, 4, 5, 6. Divided by, and the bottom you'd move it 2 spaces to the left, 0.0103. That looks like an ugly, ugly problem. But it's actually really simple with scientific notation. Well, how do we do this? Well, you just group the decimals and the times tens together. So this would be the same thing as group them together. 2.94 divided by 1.03 times, and then you group these guys together. 10 to the 8 over 10 to the negative 2. Notice by doing this, we have properties of exponents on the times tens bit. Yeah, you do have some calculator work. You still got to use calculators for this part, which we'll go ahead and type into our calculator. So that's about 2.85 times 10, and then we just go ahead and use properties of exponents. When we divide, you subtract top minus the bottom. So that is 2.85 times 10 to the 10th power. When it comes to scientific notation, unless it explicitly tells you to expand, you can leave your answer in scientific notation. But you always got to check, is the decimal number between 1 and 10? And the answer is yes. So this is a good scientific notation answer. If it was less than 1 or bigger than 10, you would have to move some decimal places. Right. Let's go ahead and do another example here. Suppose I asked you to, let's do a multiplication problem here. What if I asked you to multiply 4 times 10 to the 3rd power times 7 times 10 to the negative 2 power? Well, the idea is you group the decimal numbers and the times 10 separately. So this is the same thing as 4 times 7, and then 10 to the 3rd times 10 to the negative 2, right? All I did was I put the decimal numbers together, and I put the times tens together. And since everything was timesing each other, this is legal to do. And then you just do math. So 4 times 7 is 28. I didn't need to calculate for that. Times 10, and then properties of exponents say you add the exponents. 3 plus negative 2 is 1. Now, technically, this is a fine answer, but it's not scientific notation. Notice how the decimal number is bigger than 10. So whole numbers, the decimal is always at the end. So I want to move him. So then I got to move him one space. 2.8 times 10. Now the question is, what does this exponent become? All it is, the idea is you want to balance, you want to counteract. So notice what happened to our decimal number. We started with 28 and we ended with 2.8. So here's the idea. We made the decimal number smaller. Right. So I went from a 28 down to a 2.8. I made it smaller. Therefore, we compensate by making the exponent bigger. Right. That's it. That's the idea. Compensate. Make that cleaner. There you go. So I know I moved the decimal space 1 over. So I need to change the exponent here by 1. Well, since I made the decimal number smaller, I'll need to make the exponent bigger. Well, if I move 1 decimal place, I make the exponent bigger by 1. 1 bigger than 1 is 2. There is your answer. So there you go. Those are the 2 things I'll be asking you to do in 5.1. Can you simplify expressions? And can you multiply and divide scientific notation numbers?